All right. I know some of you guys still working, but I'm going to start looking at these. This very first problem needs to be easy. If it's not quite easy yet, it needs to be easy soon because it's an exactly problem. I only have to use one formula then if it's exactly something. If I say more than, less than, you might have to do more than one formula like on part B. So exactly 13. So what do I know? Let's summarize what I know. This is a really smart thing to do. Tell yourself what the shit you got. What's N? 22. What's P? 0.68. Immediately make it a decimal. If you put 68 into the formula, you're going to get some funky ass answers. It's going to be like 1,000,000% chance. No. Nothing's 1,000,000% chance. That's a problem. So what's Q gotta be? Yeah, because P and Q have to make 1. Not a big deal. So then I got 22. I want to choose how many? 13. So I got how many of these? 13. And then how many? These. The rest. I like it. And again, I've said this so many times already, but the formula looks worse than what it is in practice. The little n minus x, people are like, what the shit's... No, it's just the rest. If 13 are there, that's got to be 9. Because there's 22 total people. Right? Don't let that be anything more than that. And then what do you guys get plugging that in? Yeah, cool. All right, real quick, just to show you, in case you have issues with that. So 22. Choose 13. I want 13 of those bad boys, and I want 9 of those bad boys. I like it. This guy, what I'm going to do, the question asks this. I'm going to do 1 minus the opposite. I'm sorry, the question says this. Get in there. I don't want to do that, right? So I do the opposite. This one has about 21 formulas to use. This one has 2. So let me figure out what this is. Right, that would be doing it for 21. Get out of there. Is everybody with me? What's at least 21? It's going to be 21 or 22. So I'm going to figure out the opposite probability, and then I'm going to do 1 minus that. So then I'm answering the question. So how many 0.68s do I want? Thank you. 21. So how many 0.32s do I want? Hey, all right, sweet. Plus 22, choose 22. So now I want 22 of these bad boys. So how many 0.32s do I want? None of them. Sweet. So here's how to do this so you don't have to worry about the little e dude. Put all this shit in at once. So 22, choose 21, 0.68 to the 21. So I'm just plugging in the formulas we just figured out. Plus, now some of you guys know I don't have to write all this stuff, but I'm just going to write all this stuff just because. 22, choose 22, times 0.68 to the 22, times 0.32 to the 0. Now a lot of what I just wrote is stupid. Not really, but what is anything to the 0 power? 1. How many ways can I choose 22 people from 22? 1 way. So that's 1, that's 1. This is the only thing that really is a number, right? But do you have to know that going in? No. Is it going to change? No. Who cares? So this is not the right answer. That's the opposite of the answer. So then I just do 1 minus second negative. See? The little answer button means the last number on the screen. Bam! Now, some of you guys rounded this incorrectly, but what should that be? 9977. Here. All right. Everybody cool with that? So this is that at least one idea generalized. You can always do 1 minus the probability of the opposite. When do you want to do that? When the opposite has a lot less work to do. Yeah. Okay. All right. So what about number 2? What do I know? NPQ. What do I know? N is 211. P is 0.12. So Q has to be 0.88. Because again, P and Q have to make 1. So then I have 211 people. For this first problem, it's just like this first problem. I want to choose 19 of them to be successes. So how many successes do I want? I kind of like that it's repetitive. I want 19 successes. So how many successes? 19. And then how many failures? 192, so that these two make 211. So that's the n minus x piece of the formula that looks so freaky, but we know what it means. It's the rest. That's all it means. And what do you guys get when you do all that? We're not going to tell you, Jeff. You're really not going to tell me. What is it? 0.0362. Yay! All right, sweet. 0.0362. How's everybody doing so far? You guys all right? These are exactly the kind of questions I like to ask on, I don't know, a quiz or a test. How do I find these two? These are the best formulas yet. This is an NPQ problem, so when you look at your formula sheet, you're going to use the ones that have N's, P's, and Q's. By the way, I'm going to put the formulas on the quiz. So don't worry about a formula sheet yet. We'll make a formula sheet for the test. Okay. So what's the little formula for the mean? N times P. Can you see all that? All right. So that'd be 211 times 0.12, which is who to what? Stay with me now. Standard deviation is square root of NPQ. Square root of 211.12, 0.88. Let me do that in my head real quick. 4 points. Yeah, right. I didn't do that in my head. So you guys get that one? I like it. Standard deviation, no matter where we are, no matter what problem you're working on, has to be at least how many places? 3. Probability has to be at least, or pretty much exactly 4 places, right? So if you just make everything 4 places, you're kind of covered. Does that make sense? I think I said that way earlier this semester. How do I find the max and min? Usual. Yeah, I want to go up and down 2 standard deviations. And why is that? If I go 2 steps out, and the standard deviation is the average distance from the mean to the data points, and I take 2 of those things, I should catch most of the data. So if somebody had a height that was more than 2 standard deviations up from the mean, they are really tall. I'm going to do a double take when I see this person because it is unusual to see that tall of a person. So the word we use actually matches up with the idea. I love it. We don't always do that with math. So this will be, where'd it go? 25.32 minus 2 of these. And I'll just do it all in one thing. And plus 2 of those. What do you guys get for the min? 15.8 something. And then what's the max? 34 points, blah, blah, blah. Okay. So, of course, we're talking about people. So I'd say at least 16 and at most like 34. So if I saw 14, is that unusual? Officially, yes. So this is kind of our official definition of unusual. Don't write the word official, Jeff. Yes. 14. So what you can do real quick, if you drew this over here, this kind of question is easy to answer. 15.8, 34.76, 14. And you just put an arrow. It's outside of the usual range. Kick ass. Yes. Yes, ma'am. Yes.
Do we have to draw it on the quiz?
Do you have to? No. It just is a quick way to show why. Because you know on the thing I'm going to put y. So don't just say, yeah, I think it would be. No, you gotta show me some reason why. Okay. And we did number 3 last time. I'm not going to do it again. Yes.
I have a question.
Yes.
You said like when you flip a coin and like you get.
Oh, cool. Keep going.
Why
Sorry.
is that like not unusual if you get like 506?
All right, here we go. I love it. It's like I planted you here. So let's say I flip a coin 1,000 times. This is a beautiful example. And I think we talked about this before. Number one, it's unusual because what the shit are you doing in your life if you're flipping a coin 1,000 times? But maybe you're in the DMV and you forgot your phone. I don't know. Or is that bad? Okay. That was just me. So how many heads would you expect if the coin was fair? If you flipped it 1,000 times, you would expect around 500. Remember, the expected value is another name for average, and the average is n times p, but that's easy. It's half of 1,000. So when does it start to get unusual then? I think I asked you this before. If you got 503 heads, would you go, oh my God? No. But definitely, if you got 900 heads, would that be unusual? So that would be evidence that the coin has been tampered with. It's not proof, because it's not impossible to get that, but it is highly unlikely. It is unusual. So now we know exactly how to figure out how far away from 500 does unusual start. How do we do it? Well, probably the way we just did it. Paper. Are you paper? Yes, you're paper. So say I have 1,000. You got to do this, Jeff. There you go, buddy. I have 1,000 flips of a coin. So what's P and what's Q? 0.5, 0.5. So what's the mean? We already did that. Half of 1,000, I expect 500 heads, right? So we're talking about heads. Well, what's the standard deviation going to be? Yeah, they're 500. All right, somebody can help me out on that. 250, it's like 16. Is that right, Jeff? I don't know, Jeff. That sounds about right. It's around 16. I like 15.8. 811. Like that? Okay. I'm sorry. I was really far off. So, where would unusual start? Here's 500. I would go up 2 steps, right? So go up 2 of these, and that would be roughly 32 almost. You guys see that? All right, let me try this again. Is everybody cool with the mean and the standard deviation that we got? Is everybody cool with that? Is everybody able to shake your head like this? Is everybody able to do that? Yes, okay. No, all right, shit. It's gonna make interaction difficult. You always can do this too. Yeah. So everybody's cool with the mean and the standard deviation? Thank you. That is the correct way to respond to that. Now, all I'm doing, we know the definition of where unusual starts. For now, it's going to be 2 standard deviations up and down. Outside of there is unusual. If I'm talking about heights, that would be very small, short people and very tall people, right? Okay. So where do I end up if I add 2 of these? 531 point blah, blah, blah. Doesn't really matter. And if I subtract 2 of them, I'm going to end up around 468 almost. So officially, if I flipped a coin 1,000 times and I got 540 heads, that is some evidence that the coin has been tampered with. Is it strong evidence? No, it's not that far above that. But it still is unusual. Obviously, 900 heads would be strong evidence. Holy shit, that's really unexpected. 540 is sort of unexpected. But if I get anything in between those 2, that's fine. That's what I expect. I expect around those 2, right? Yes? If you flipped a coin 1,000 times and you got exactly 500 heads, wouldn't that be a little weird? Yeah. I like it. So I really want you to understand this. Is 500 heads unexpected? No. But it would be a little weird to get exactly 500 heads, right? So the probability of 500 is actually smaller than 5% chance. Why? Because there's so many things that could happen. So I don't define unusual based on the probability of a single thing. I define unusual based on how far away from the mean I get. Because I expect it to be around 500. Okay, maybe. Maybe. Okay, so I love that question, Rune. I didn't step on your question, right? You got the whole thing out? Okay. All right, so what we're going to do now, let's look at the other side of this bad boy. Some of you guys have already looked at this a little bit. Did I start you? Yeah, that's probably better. First couple things, I'm just going to do real quick, right? 14 flips of a coin, 50% chance. Let's probably get exactly 9 heads. 14 choose 9. And some of you guys might realize if it's 0.5, 0.5, I could just always put 0.5 to the 14th there. If you don't know what I just said, then it doesn't really matter. It doesn't change anything. So can anybody do that yet? Somebody with me, flip a coin 14 times. 50-50 shot. Getting heads, and I want 9 heads. Let's see, I'm just going to do it that way just to be quick. 1, 2, 2, 2. You guys, is that cool? And real quick, just to show you, it's really smart to kind of look at this table I made over here. I didn't actually make it. I just stole it from somebody. But see what this means? How many successes could I have? How many heads could I have? Anywhere from 0 to 14. Let's probably get 9 heads. 0.122. So this table I stole it from, rounded to 3 places because they're crazy. Okay. You guys all right? You guys doing all right out there? So why does it make sense that the highest point is 7? Because that's the expected value, right? That's what I expect. So the most probable thing should be close to the mean. Because the mean is the expected amount. So it's what I expect to happen. You guys see that? Is that cool? How about this one? How would I do at least 1 head? Yeah, 1 minus probably that I get how many heads? What's the opposite of at least 1? None. So then I just have to do, if I do this formula, 14 choose none, 0.5 to the none, 0.5 to the 14. Just to cut to the chase, that's the only part that really matters. How do I interpret this? Is the answer 6? There's a 600% chance. How do I interpret this? Times 10 to the negative. So how many zeros in front of the 6? 4. Kick ass. Move the thing back 5 places. I'll get 4 zeros. So it's 1 minus 0.00006, which is 0.99994. Kind of makes sense. If you flip a coin 14 times and you don't get any heads, is that weird? Yes, it is. It's already weird. Is it impossible to get 14 tails in a row? No. It is weird, though. You would mention that to somebody. The other day I was bored as shit and I flipped a coin. I got 14 tails in a row. Holy shit. Well, now we see why. It's a very small probability to get nothing but tails. So it's a really high probability to get at least 1 head. Okay. And then real quick, here we already basically did this. The average number of heads out of 14 flips should be 7. That makes sense. Standard deviation, though, what's that going to be? N times P times Q. What do you guys get? Who is it? 1.871. So then what's the minimum number of heads I expect? 7 minus twice that. Right? 7 minus twice this. Watch this neat trick. You ready, kids? Second enter plus. Oh, I just saved myself so much. No, you didn't, Jeff. Oh well. Here's something even cooler. Kids, holy shit. There's the standard deviation. You with me? I'm about to do something you don't have to do it at all. But I'm just going to show you because it's got broader applications. Watch this. Times 2. So that's 2 standard deviations, right? Right? Okay. Store. See the little button stow? Store it in X. Bam. Then I can do 7 minus X, 7 plus X. Ooh. All right. Anyway, do you ever have to do that? No. Calculator costs $100. It better be able to do shit like that, though. So what do we got? We got like 3.26 up to, where'd it go? 10.74. So would it be unusual to get 11 heads if I flipped a coin 14 times? Yes, officially it would be unusual. I like it. Okay. We already talked about this, but this sheet I made a while back, but it was always kind of like in a weird place. But this is just really eventually showing you about the area, and that's what is important. So if I want the probability of at most 6 heads, I'm just going to add up all the probabilities up to 6, right? If I just add up all these probabilities, and that's going to be the total area from 0 to 6. So that's the whole idea behind the uniform probability that we did. I think you get 0.345 if I remember correctly. It's been a while since I did this, but if you add up all these, 2, 3, 4, 5, 3, 6, 7. I think it's 3, 4, 5. Somebody's going to check me. All right, so that is a little extra confirmation about the idea that if I visualize a probability distribution, a question about probabilities is equal to the area related to that question. So if I want from 0 to 6, I can just add up all the areas of these rectangles and I get the answer. And that's what we did with these guys, right? Remember these guys? Is that formula okay? Do you guys notice what that is? That's the reciprocal of the length here. That's exactly how to figure out the height. I like it. And then finally, we got this dude. We can finally talk about this guy, which is what we're going to do for the rest of the time. Oh, shit. And I think I already made the point about rectangular areas easy. We're all over the fact that if I represent a probability distribution visually, a probability question is related to finding the area related to that question. Bam! And I even looked at a triangular one last time, didn't I? A little bit. We don't have to worry about triangular distribution, but just to make the point. What's wrong with the normal curve in terms of us trying to apply geometry to it? One side is going to be curvy. You can see that in the name, normal curve. Oh shit. Does your geometry have formulas for curvy-sided objects? And I don't mean circles. Yeah, you guys, is anybody with me at all? So if it's a big-ass rectangle and every slice is another rectangle, shit, I can find probabilities easy because it's just finding the areas. If my shape is a normal curve and I want to find this area right there, that is not a rectangle. It's got one side that's all freaky. I don't have a formula for that. We're not going to learn calculus. We're just going to use results from calculus, because one thing calculus does is it calculates the area underneath any freaky curve. So we're just going to stand on the shoulders of people that know calculus. Okay. So we're almost there. We're almost there. Almost where, Jeff? I don't know. We'll find out when we get there. neat part of the video. We had a little earthquake. Poor little dude.